Hello, just hold on a second, guys. We'll be starting off with the webinar soon. Just waiting for everyone to join in.
Hello, Sankha. I'm in. Thanks.
Yes, sir. I'm adding everyone. Hello. Just hold on a second, everyone. We'll be just starting off with the webinar soon. Just waiting for everyone to join in.
Hello.
Yes, sir. You're audible, sir.
Okay. Sanka, give me permission to share my screen,
Yes, sir. Doing that.
please.
Yes, sir. Given. Can you see the option now?
Yes. Can you see my screen? Hello.
Yes, yes, sir. We can see your screen. Yes.
All right. Thank you everyone for joining. We'll be starting up shortly with the next 4 minutes by 3 p.m. Hello everyone. Thank you for joining us. My name is Ankit Sahu. I'm the director and co-founder of Objectty Technologies. It gives immense pleasure for us and for our team to do the second series of our webinars. And so we will be starting very shortly on the same. And we did a webinar series from April 2nd to April 14th, and we got an overwhelming response uh, during that time. And it was on the introduction of the additive technologies, where Objectify showcase their capabilities and the capacity and the understanding about the technology. And from that, we got an overwhelming response on some of the topics like conformal cooling, topology optimization, the power generation, implementation of additive technologies, and the disruption of supply chain post-COVID, which can be catered by additive manufacturing. So today, on this day, 23rd of May, we will be ideating on the conformal cooling technology, and it gives me immense pleasure to be present here and showcase what the technology is all about. And we would be also showcasing some of the cases Objectify has been able to deliver to their customers, to their partners, to solve a real-time problem with the technology in hand and the technology in talk today. And so slowly everybody is coming out of this the great lockdown of COVID-19. Everybody is coming back to their offices, their factories. They are starting up soon. There will be a lot of pending activities which are required to be done in the regards of sufficing with the current overrun of the requirement of their end customers. So that's how, like, we wanted to start talking about the technology itself, and we wanted to showcase about this technology. So today with us, there'll be three more panelists who will be joining us. So Mr. Abhishek Tiwari from Moldex 3D will also join us. Mr. Kripal Bedi from Sridevi Tools, he'll be also joining us. And Mr. Virendra Singh Bhadauria from MotoCorp, the tooling division head. He will be joining us in the full capacity to explain what is the beauty of the technology we are talking today, and we will be talking in depth about the current scenarios and the technology in focus. So good afternoon, everyone. Thank you for joining in. And so as I've told you, we are going to talk about conformal cooling. And we did prior to this webinar series in the month of April already, regarding innovators at home. So we discussed about the technology of additive manufacturing, 3D printing 101. We explained about the technology, what it's all about. We explained the application and the decision making of implementing the additive manufacturing technology in itself. Then we talked about tools and rules. So tools and rules were like the key takeaways from the technology itself, and it was showcased about Objectify's capability, and we showcased what are the procedures, what are the processes you should be following for implementing the additive manufacturing technology itself. And the third webinar was on the application side. So which industries, what kind of projects right now people are doing, and what kind of projects people can think about in the future they can do. So we talked about that. Then after that, we were talking about the learnings and the misconceptions about the technology. So a lot has been said in the media, a lot has been talked about, a lot books were there, but the real time problem statements which were needed to be defined were missing. So we talked about in our 7 years of experience. So we did that webinar series because we were celebrating our 7th year of existence on April 1st, 2020. So we talked about our experiences in the industry, and how we were able to solve those key problems of our customers. Then we talked about the challenges about the technology and the current demand of the industry. There we had three presenters who presented with us, Mr. Rajesh Khanna from TVS Motors, Mrs. Deepa Srinivasan from Pratt and Whitney, Mr. Anil Kumar from Vikram Sarabhai Space Center, ISRO. So they were our esteemed guest speakers during the our last webinar, which we did in the first half of the April. So Sankar, can you share the poll?
Yes, so sharing it right away. We'll be seeing a poll right now. I would request everyone to just submit your answers. The poll is regarding the last webinar we had. Yes, the poll is live. You'll see it pop up on your screen. I would request for you to give in your answers. Yes, sir, the answers are coming in.
All right. So I think most of you have got the poll, and you might be getting delivering your answers right now. So moving on to the topic of conformal cooling. So we have to go back. Conformal cooling is basically a very good indirect use of the additive technologies. So it is mostly used in the injection molding or metal injection molding or die casting technologies where you are using formative ways of making a component. So today we are going to talk in depth about injection molding as a technology. So injection molding, most of you might be experienced with a lot of plastic products in your lifelong, and most of these products are injection molded, be it from the caps and closure for your shampoo bottle, from the automotive vehicles you're driving around. So most of these components are manufactured through this technology. Injection molding is a technology of transferring plastic material from pellet size to liquid base and then formative into a mold and cavity, and it takes a shape which is preferred in the mold and cavity itself. So this is the technology we are right now in focus with. So the importance
So
of
the poll
injection.
answers are ready. Should I publish them?
Yes, please.
Yes. So 60% are new people, and 40%
Great.
are just are the ones who have come from the previous webinar.
Oh, great, great. So it's a good audience we have today, uh, who have experience about what additive is all about, and we are going forward from with it. Uh, in injection molding, the most important part is the how you are reacting with the liquid phase of the material. The cooling of the material is very important, and it is also important to take care of the shrinkages and the warpages in the process itself. So what people have been doing for the cooling side, they have been till now, because of the limitation of the manufacturing process, they have been conformal cooling example is our human body itself. So the human body also takes up the shape, the veins, and the cooling effect is along the geometry itself. So that's how the conformal cooling technology, it's conforming to the design of the component, and it is nearer to the component for it to freeze better, for it to solidify better, and for it to in conventional way of directly drilling or milling the surfaces. So what people generally do is they take care it with the additive technology which Objectify offers to its customers. So as you can see, the 50% more than actually 50% is the cooling time. So if we are in the cycle time, the whole cycle time, the injection time is 10%, the removal time is 20%, the setting time is 20%, and the cooling time is 50%. So in general, these numbers are in general. So if you are able to reduce this 50%, then your cycle time is also reducing significantly. And if your cycle time is reducing significantly, then your productivity improves, because you will take lesser amount of time to produce the larger amount of components in it. So that's the basic psychology of a commercial level engagement with a customer, so that we can explain these things to them. So you can see from 87.33% of the cooling time, you can reduce it to almost like 16.67%. So that is a huge, drastic reduction in the cooling phase, and in turn improving your cycle time and improving your throughput. So Sankar, can you do the second poll also?
Yes, sir. So we'll be bringing the second poll right now. Expect everyone to give your answers. So the poll has appeared on your screen. Kindly give your inputs and submit it. So the poll is running.
So with this poll, we wanted to understand what is the level of engagement for you with the technology we are talking about, like injection molding or die casting, so that it becomes easier for you to understand and easier for me to explain as we are going ahead with the presentation itself. So Sankar, you are getting answers?
Yes, just a couple of seconds. We are almost done with almost all of the response. 80% people have already responded. I would request everyone to, as soon as the poll appears, just give your inputs so that we get to know the kind of audience. Yes, so should I publish the results, sir? You can see it on your screen.
Yes. Yes.
Yes. Can you see it, sir?
Yes. So as expected, most of the people are intermediate, aware about the technology. So, and some are experts and advanced level engagers in the field of injection molding. So that's great. And as we can understand that 27% are having the fundamental awareness about the technology of injection molding. So that's great. So everybody is on the same level. So as I told you in the previous slides, like conformal cooling is a technology of conforming with the design of the component itself, in turn cooling it better, and in turn giving a better quality product with a lower cooling time, in turn increasing the cycle time of the component, and also increasing the throughput. So this is how like most of the designs are carried out. And and you can do like spirals, because you are additively manufacturing these inserts and the core and cavity. So it brings a good this thing. So you can see like most of the people who are the decision maker, the decisions are not only on the technical side but on the commercial side also. So it should make a commercial sense for somebody to implement such a technology, because conformal cooling technology, because it is additively manufactured, it is not as apple to apple comparison as compared to the conventional way of making it. So it is a bit expensive as per as you can see. But in turn, in the product life cycle, you will be gaining a lot of profitability through implementing such a technology in your tools and molds. And you can see the profit if the conformal cooling is done, and if the cooling time is reduced by 20%, you can see there's an increase of profitability by 27%. And if you're reducing the cooling time by 30%, your profitability is increasing 41%. So you can see with a linear increase of the cooling time reduction, you're seeing an exponential way of increasing the profitability. And this is the way forward for the industry and the decision makers. So they do their analysis on their return on investment on the tool. So this is where like the main core thinkers and main core ideation people think about, as expensive and as complex the part is, there is a greater requirement of this kind of a technology for it to cool better, reduce the cycle time better, and increase the profitability. So if it is a very cheap kind of a product, then conformal cooling is as good as a normal technology itself. So but you're paying an extra buck for it. So that's how like the whole agenda is. So as complex as the part is, as complex as the molding procedure is, the conformal cooling will be a good option for you. But as simple as the component becomes, then the conventional should be the answer for you. So this is the decision making on the strategy front, on the commercial strategy front. This is how we wanted to showcase about the technology implementation currently. So there are certain design parameters, and we have taken this parameters with EOS. So EOS is our OEM partner who has been helping us out. So Mr. Ram Kumar, he is also joined us today, and he has been like primary force in India who has been implementing this technology ever since, and he has been giving us more inputs, and he was the first person to give us the thought process. So these are like some of the parameters how you should design your conformal cooling channels within the core and the cavity, or the inserts or the sliders. So these are like thumb rules we wanted to showcase. Like let's say there is a wall thickness of 0 to 2 mm, and so the whole diameter should be 4 to 8 for an effective cooling. If it is 2 to 4, then the effective diameter will be 8 to 12 mm. If it is 4 to 6, then the effective diameter. So these are like certain thumb rules we should take care of when you're moving forward with the technology, when we are trying to design the cooling channels inside. Because in the additive side, it will be easier to manufacture, but it should make sense for you to utilize it for the tool cycle life itself also. So that is the major way we should look forward with the technology currently. So here is a small example of comparison of the data from a fan manufacturer perspective. So you can see the cycle time, the cooling time was 33% in the existing cooling scenario, like the setup, the cooling setup. But if the customer was changing from existing with the beryllium copper, it was reduced to 16 seconds, and it is it's a major uh, beneficiary for the customer also. But having said that, beryllium copper also gives you a big time challenge when you're going ahead with X number of molding. So let's say after 400 or 500 shots, your tool also gets heated up because it is sustaining that amount of heat. But if you're using conformal cooling, the movement of the water or the media inside the inserts itself will be moving around, and it will be cooling the channels inside again and again. So you can see with the existing setup, with the conformal cooling, by just changing the core insert of the fan model, you were able to reduce from 33 seconds to 10 seconds. So that is a exponential beneficiary for the tool maker, for the molder, for the end user, and for the end customer like us. So a lot of quality challenges were there in this model, a lot of rejections were there, uh, lot of complaints were coming in. So what we have understood by talking to these injection molders, to these mold makers, and to the OEMs is like the profitability lies not in making the X number of component, but the profitability lies in actually reducing the number of rejects. So that's how like you are making your business proposition more stronger for your organization and moving forward with the implementation of newer technologies like conformal cooling. So you can see it is a detailed study. So you can see here the cooling time has been reduced like from 33 second to 16 second to 10 seconds. So it is a phenomenal increase of productivity for the customer and phenomenal in quality improvement for him. So this is another case where reverse osmosis project part was done. So you can see the hot zones in the component. So what we generally do is like we simulate these components on our Moldex 3D softwares, and we try to run behind the hot zones. And as we are catering those hot zones, we are able to increase the part quality and part efficiency, in turn reducing the cycle time and the cooling time. So it turns like because people understand money better, so we are talking about the cooling time and everything, and the cycle time, but the major application is on improvement of the quality of the product itself. So that is where we are implementing this technology with our customers. So these are like some of the design side. We just wanted to show you how the designing is done. So we have in-house designers with us who have been doing such beautiful projects for our customers and getting a applause from the end users also. So here you can see the pink portion is conventionally fabricated because these are like straight holes, and but on top we can deposit certain material which will reduce the cost of the product and in turn be beneficial as equivalent to printing or additively manufacturing the complete insert itself. So this is how we are also consulting our customers in reducing the cost for the insert produced on conformal cooling, or also increasing their understanding with the technology better. So you can see with the previous this thing, this cooling time has been reduced from 105 second to 77 second. So there is a increase of more than 28 second as, and you will be able to do in every 5 shots you will be getting 1 shot extra. So everybody understands a free concept within India really well. So you can understand from that perspective. Earlier you were doing 5 shots, now you're getting the 6th shot free with the 5 shots time itself. So it is a good understanding the technology from that perspective also. So impact of Objectify with their customers. So we have executed more than 250 plus projects with printing more than 500 plus tooling inserts for our customers. We have been doing 100 plus projects for metal injection molding companies within the country, and we have also executed 10 plus die casting application project, and we have done a lot of simulation projects on Moldex 3D for our customers, where actually they are trying to understand where they should provide a gate or a runner or those kind of things. So we have been doing those kind of projects also for our customers. So those are like few of the services, add-on services, what Objectify also does. So this is a basic breakup of Objectify's revenue. So 50% of our revenue comes from the metal side of the business, 40% comes from the plastic side of the business. We also do polymer additive manufacturing. We also take up designing project or machining projects, such as like the simulation project, as I was previously mentioning it to you. So tooling for our whole revenue breakup, you can see from the metal side itself, it's almost like 25%, which is like 1/4 of our revenue itself. So we have been serving really well with our tooling customers, and the country has been taking the technology really seriously, and they have been trying to engage better and being more competitive with their competition, not only in India but outside India also, as you can understand from the current situation and the motto of our great Prime Minister Mr. Narendra Modi of Go Local. So these are like some of the few technologies which have to be implemented really well within the country to increase the productivity of the country and to improve the product quality also. So you can see on the left of your screen, you can see what kind of tooling projects we have done. So 25% of our tooling projects were for automotive, 20% were for white goods, 25% for the electrical equipments, and 20% we have done for FMCG, so caps and closures and bottle blow molds, those kind of things we have done quite well. And also we have been doing with the medical, so a lot of syringes tools, a lot of medical devices tools we have been serving really well. So 10% comes from that end. So we what we have understood since with our operation for last 5 years, this is how the decision making has to be done, and this is the benefits what the customers get. So we are following the money. So the money is from bottom to top, but the decision making happens from top to bottom. So we have to take care of the mold maker. So he has to be more competitive and promise a good throughput on the tool itself to its end user, and he has to be able to convince his end user that the tool design is the best for the quality of the product and the reduced cycle time. So this is how the decision maker for the and the beneficiary for the mold maker is. Then for the injection molding companies, like the converters, if you say, so for them the beneficiary is the higher throughput, lesser the wastage, higher the quality of the product, and higher the tool life, because you are able to cool each of the tools better because of the conformal cooling. So your life of the tool also increases because of this motivation itself. So for them, the benefit is that they are getting a low cost product with a higher efficiency in the supply chain, because there is a reduction in the rejections, and they are getting faster deliveries, because let's say they were getting X numbers in a month, now they're going 3X in a month. So they are able to make more of the final goods for the customers. And for the end user, which are the end customers like us, for the end user itself, it is a better design product, cheaper cost because the quality has improved, and the cost has been reduced because they are able to the supply chain has been able to make the components with a efficient way of making the product, final product itself. So you can see from this graph how beneficiary the reduction in cooling time is. You can see again what is difference between doing from the conventional way. So you can see a lot of hot zones. So we can see we can understand colors. So red being the hottest area, blue being the coldest area. So you can see how many hot zones are there if you're not doing conformal, and how these red zones change into blue zones if you're doing conformal. And there is a reduction in the temperature graph. You can see the left hand side product is going up to like 114 degrees, the right hand side product is going only till 69 degrees. So it is like how you tackle the heat dissipation in the tool, how you tackle the heat dissipation in the component itself, and in turn you're improving the quality of the product also. You can see in the conventional you're seeing a bit of bord pitch in the component, but with the conformal you're getting better results, better output. So this is the basic gain of the technology, where it should be implemented and to improve the product quality itself. So you can see here, like this is one beautiful project which we did. So from beryllium copper, the cooling time was 55 seconds, but from conformal, it went down to 25 seconds. And this is a good example where you are not able to cool inaccessible areas, and you are able to do it with additive. And you can see a different design of the cooling channels inside, which you cannot do manufacture in any other way, which you have to work with additive technology itself. So here you can see example of switch gear. So here again the cooling time has reduced from 8 seconds to 3.5 seconds. So I can tell you a basic difference. When we were doing this project, the tool maker was going from a 8 cavity mold to a 16 cavity mold. And we said we will take up this project, and we reduce the cycle time, in turn doubling his capacity, in turn his reduction in the captive cost of again to making a tool and again implementing onto the injection mold machine. So we had reduced that kind of a profitability has also increased. So you can see the warpage difference, also the product quality. So from 0.31 of displacement, it came down to 0.11. So it is a great gain for the end user. So here is an example for a syringe manufacturer. So the cycle time reduced from 28 second to 14 second. So this is a chain cover for an automotive. So from 65 second, we were able to reduce it to 35 second. And the greatest thing here is like the customer was using almost 6 fixtures after molding just to regain the shape again. So now after molding through conformal cooling, he is getting a warpage only of 3.8 mm. He has only one fixtures to work with. So it is reducing his infinite cycle time to a finite level, and which is commendable for the customers also to use. The warpage which we are talking about. So this is an example for caps and closure from 21 second to a 12 second. So it is exactly like an exponential growth and exponential profitability for the end user. So this is a sprue bush for a white good manufacturer for a kitchen mixie. So from 55 second, it reduced to 30 second just by changing a sprue bush, which costed him almost like 35,000 rupees, and his productivity also increased. So you can understand what level of profitability on the tool, on the moldings, on the end products the customer is going to make. So again, on the caps and closure, this is the way we print. So we align these components onto the build plate, then we print vertically, and this is the way we have been able to deliver it to our final customers. So in the die casting also similarly, so in the die casting, the challenges are more towards on the quality side. So we were able to answer these questions by doing the conformal channels inside, and we were able to do this hybrid way of manufacturing these inserts. And you can see the way it has been manufactured. So here is an example. So this is the cooling channel area. So we have conventionally manufactured the whole base, and only the area where the conformal cooling channels are there, we have only used that area for the additive manufacturing and deposited the added material. So you can see here an example here. And the top portion then we finally machined through our CNC machining process. And this was the end use product for our die casting customer. So the good part is you are able to reduce shrinkages, you are able to reduce warpages, you are able to reduce the cycle time, which in turn is giving you economical advantages. And also the tools are becoming more efficient, and you are able to eject faster, and in turn you are increasing the life of the tool and increasing the number of components out of the tool. So these are like the mantras how additive manufacturing on conformal cooling should be looked upon, and this is the way Objectify is trying to help their customers base. So Sankar, can you put the last poll?
Yes, sir. Putting the poll right away. Yeah, so you can see the poll is on your screen right now. I would request everyone to submit their inputs.
Sankar, you are getting answers?
Yes, the inputs are coming in right now. The answers are coming in.
Great.
People are currently voting. Yes, so it has been 56% and counting. So I would request everyone to please fill in your answers. Really helpful for us to understand. And meanwhile, you can submit your questions in the Q&A section as well. That will help us a lot in answering you in one-on-one.
So, Sankha, you're done?
Yes, 67%. Should I end the poll and publish the results?
You can end it at the end. You can take the poll.
Sure,
I'll finish
sure.
off with this.
I'll let you know.
All right. So on the material side, on the conformal cooling, on the tooling side, we are able to work with margin steel, which is a 18Ni 300 material, which is equivalent to how you work with your H13s and H11s. So, and also we have Corex CX, which is a material for corrosion resistance. So a lot of like FMCG from the food side try to use this material, where the problem is on the corrosion side. And also we have developed H13 onto additive manufacturing direct implementation. And also we are working with 13Ni 400. The beauty of this material is the hardness we are working with. Also we are working currently with A2 steel. So these are like few good materials we are able to serve the tooling industry way better. From the start, we started with just two material, MS1 and Corex. But as the customers are coming back to us, can you do in this material or can you do in that material? Because that is the comfort zone of our customers. So we have to answer those queries for our customers itself. So these are like few of the materials we are working with. So I would like to invite Mr. Abhishek Tiwari, who is head of Moldex 3D in India. And Mr. Abhishek, can you hear me?
Yes, Ankit ji, thank you. I can hear you.
Yes. So I would like to introduce Mr. Abhishek Tiwari, and I would like to introduce Moldex 3D. Moldex has been working with Objectify since I think now it has been the 5th year running, and we have been in great hands with the Moldex team, and they have taught us a good way to serve the industry better, and they have been a prime partner in solving the real-time problems of our customers. They have been helping us out in the 11th hour of the project also. So Abhishek, do you want to introduce yourself somehow? Yes.
Ankit ji, first of all, I must say that you gave a very good presentation, and thanks for inviting Moldex 3D. I think the introduction which you give is good enough for industry to understand what basically Moldex 3D can do. So we can continue with the session.
Yes. Mr. Abhishek, so can you tell me like how are people taking simulation as a solution in India? Because slowly and steadily everybody is asking for scientific data. So how are you seeing the market? How are you seeing regions responding? Because India cannot be considered as a single country. It is like European Union. So every region behaves separately. Every person behaves separately. Every company behaves separately. So how are you seeing the trend of implementation of simulation in India?
Sure. So yes, in industry, simulation is playing a key role for validation of design and for risk assessment at design stage itself. So it is always better to validate your product design and tool design before freezing it for manufacturing. And that is why, simulation is helping in taking right decision at right time, especially in conformal cooling. As you know that inserts are once printed cannot be modified.
Exactly.
So before printing of inserts, it's always better to validate the design best cooling option for those kind of inserts. And that is how simulation is helpful in eliminating trial and error for saving time and cost. And these are the two key factors in industry everyone is running behind to save time and cost.
Exactly. So what do you see Moldex 3D's biggest strength currently?
That's a very good question.
Yes.
Yeah, that's a very good question. Basically, there are many advantages of Moldex 3D, but the most important thing I say is accuracy. With the help of advanced meshing technology and inbuilt material and machine libraries, And based on our 30 years domain experience, I have witnessed Moldex 3D can achieve 90 to 95% accuracy of results.
That's
If
that's
it's very
I can vouch for it. I can vouch
yes,
for it,
yes,
Abhishek.
yes.
Because
You're already using it, right? So
yes.
apart from this, it's very user friendly in meshing and solving the run very faster, and even the report generation is very user friendly. That it supports. Last but not the least, the support from Moldex 3D region
Yes.
team, from local India region team and from Taiwan team is also very effective. So we do complete hand holding for customers.
So Abhishek, can you tell me like which are the industries in India currently trying to implement simulation, and who are the trendsetters currently in implementing the simulation technologies and the conformal cooling technologies?
Yes,
Can you?
widely I could say that injection molding industry is the biggest beneficiary, and molding 3D simulation and our application is widely used by automotive sector, electronic sector, also home appliances and medical and FMCG sectors.
So,
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 however,
so are you seeing any kind of a trend like these sectors are like trying to implement with a strategy or something like really focused on some
see,
product improvement?
See, flow simulation is very good tool for validation of design, and it is always beneficial when you start implementing at product design stage. The trend should be to validate your design and risk assessment at the early stage so that you have enough time to overcome the potential risk factor. Unfortunately, I must admit that still we observe that customer approaches when they have already make mistake in design, or the mold is already at production stage and they are facing issues. So we must understand as an industry that using the correct tool at correct time is the key. And now I see the trend that companies in India are moving in this direction, which is a good sign. That is,
Exactly.
in this lockdown period, even Moldex 3D is giving free trial license to our interested customers, and we're trying to set the trend.
No, no, that is something like everybody should be working together. So with like customer supply kind of relationship, everybody is open for a partnership kind of a way, because
True.
everybody has to hold hands with each other and walk together. So Abhishek, can you help me like understand like how are you seeing like trend of implementing conformal cooling as a end at the end customer perspective, because you are much more involved with the day-to-day activity of a simulation project for a end customer, right? So how are you seeing that kind of a trend currently?
Yes, exactly. Basically, I will say the advantage of conformal cooling is that cooling channel can follow the part profile and can access areas which is not possible with conventional cooling. This helps to achieve even cooling of the part, which ensures better part quality and also save cycle time. So you have both quality as well as cost benefit. It's very important that rather than cooling faster, it's important to cool evenly, because that will not only reduce the cycle time but will also make sure that you have a very uniform and good part quality. So part quality as well as cost, both benefit you can get after implementation of conformal cooling.
All right, Abhishek. Abhishek, what I'll do is like I'll move forward with Mr. Kripal sir.
Okay,
So we will come back after like talking to the other guests. We'll come back with Q&A. We'll take live questions from the audience, and please help me out with those answers from you.
sure, Ankit.
Thank you, Mr. Abhishek. Thank you so much.
You're welcome, sir.
Kripal sir, can you hear me?
Yeah, I'm hearing you.
Yes, sir. Good afternoon, sir.
Good
So,
afternoon.
sir, it is my pleasure to introduce you, and you have been our very proud customers, and we have been talking about Sridevi tools. We have been talking about Kripal sir and everybody who is using LinkedIn and who is a follower of injection molding technology must be a fan of your work and content what you post on LinkedIn.
Thank
And
you. Thank you.
I've been really following you since the time we got introduced to each other. And I just wanted to introduce your organization. Sridevi Tools is one
Yeah.
of the oldest tool maker in the country, and they are one of the largest tool maker in the country, and they serve from automotive to white goods uh, to other different sectors, and they have been working really closely with the OEMs in India, and they have been able to solve a real-time problem for the end customers. And Kripal sir has been in the industry for past 25 years, and he has seen everything, I think, from the basic start of the industry, start of people talking about this as a technology, because earlier most of the things were in sheet metal or everything, but now a lot of sheet metal designs are changing into polymer products, and he must have seen that transition in his career itself. So
Yes.
Kripal sir, just wanted to start with uh, any formal introduction you want to do about your work profile and something like that. You can please go ahead.
Yeah, just for the benefit of the freshers or the people who don't know me, I have been associated with automotive plastics since about 25 years, as Ankit just said. And I have gone through the phases where we were used to, we used to cut on die sinking machines. We had only one CNC gauges used to be made to match the profiles. And then slowly the technology has evolved and developed to a stage where CNC took over, and the first mold design I made was on a drawing board, and now nobody thinks of it.
Exactly.
So, the technology has evolved, and we have gone through all these things. I was lucky enough to be associated, to be working in a tool room, to work in a tier one who is making and assembling parts, and also with a texture company for a short while. So that gives me a whole perspective to the way the things are in an automotive plastic domain.
Yes, sir.
So I would welcome any of the freshers, newcomers to connect. And then, see, we have learned the tough way, and we took a lot of time to come to the knowledge that we have today.
Exactly.
And we don't want the next generation to take 25 years to gain all that knowledge. So knowledge has to be given fast to the next generation. We as a country have to develop quickly and catch up and make use most of this COVID opportunity that has thrown up to us.
Totally, sir. Totally, sir. Totally
Thank
agree,
you.
sir. So we should work as a partner more than just a customer supplier kind of a relationship now,
Right,
and
Ankit.
it is needed as much as possible. So, sir, what are the like key takeaways you say, like, for a tool maker, and what are the order winners for you, like, as a tool maker? Because there are n number of tool makers now in the country. Why Sridevi? Why? What is the key competencies of tool makers like you? And there are several in our part of the region also.
Right. See, first of all, uh, there is a rough estimate which says that we still import about 10,000 crores worth of molds every year.
Exactly.
So there is still a lot of tools which are coming from outside of India. So there is a lot of latent demand which is not being met by the Indian tool makers, which everyone needs to capture. So
Exactly,
that is one area that we need to look into. And mold making is capital intensive. The tool rooms are capital intensive. So you need to build the trust with your customers if you want to have the continuity of your business. Your belief in your ability and your customers' belief in you, both are important as a tool maker.
Exactly.
So then only they will be investing, because a tool costs a huge amount of money. If they don't believe you, if you are not able to give the right quality every time, you will not get repeat orders. So you cannot, quality cannot be an accident for you. It has to be planned. There's a lot of hard work behind it. So our competitive edge, if you want to ask, is that, we are technology and process driven. That is what the advantage the customers get from us. So we develop processes, we keep on fine tuning our learnings. Capturing learnings is our ongoing activity every day. So we want to learn and capture on our mistakes. So this all, this is sharpening the axe.
Exactly.
So when we keep on doing it, we are able to, always consistently deliver the molds, and we always reinvest in technologies and software, and bringing best of the machines for the mold making. We are never compromised on these fronts.
Yes,
and training also goes hand in hand. So these are all the competitive advantages that Sridevi offers. One more last point that I would like to add here is that we have specific skill sets for specific sizes of the molds. We have 3 tool rooms in Vasai. which cater for small size, medium size, and big size molds respectively. So the people are trained according to each set of molds. There is infrastructure which matches that need, and there is no mixing of the talent or the mixing of work there. So that is also one advantage that we carry. Yeah, over to you, Ankit.
So do you see economics only one of the major decision maker as or the technical is the most important, or the commercial is the only decision maker for your customers?
See, tool making is a passion. Whoever is it in it, they are not baniyas, or we are not here to. मतलब पैसे से ज़्यादा सोचने वाले लोग tool maker कभी नहीं बन सकते.
Exactly.
So it is more of a passion that you are in, but then everyone is in it to make some money and continue to grow. So what is basic for us is that the technical specifications and commercial commercial outline. How do you want your mold to be built? What are the specifications that you want to put into your molds? Do you want international standards elements to be in your mold, or you're okay with domestic products which are equally good? So these all specifications will decide how costly your mold is. Once that basic outline is laid, then it is only the technical specifications which will drive the mold. A mold maker will never go on and think, "Arey, I have paid, I have got only this much, I should compromise here, cut corners here." No. We will always try to see that we give the best quality tool to our customer. A mold which is becoming a showstopper for an automotive line can be a disaster. You cannot go and show your face next time if if your mold is becoming a showstopper. So compromise is a no-go for us.
So first thing is on the technical, and then comes the commercial anyway.
Then comes the commercial.
So sir, is there a trend you see like people are much more, because I think as we are moving forward, and I've seen with the Tagma coming along, and they have been really focused in making the toolmaker industry very comfortable with the customers. So do you think like much more focused within the country, domestic production or something like that, or are you seeing still the, let's say, I'm not naming, but China being a stronghold of this tool making art because of the commercials? Are you seeing that kind of a trend?
See, Atmanirbhar is still very much fresh on our minds. So we expect to see sustained demand for Make in India. People are going to, Make in India, have that drive initially to explore and make in India. But everything said and done, we need to know that previously quality, delivery, and capacity, these have been the major reasons why business has gone outside of India.
Yes, sir.
And we cannot change these things overnight.
Yes, sir.
We will need a concerted effort, right infrastructure, improvement to show and give our customers what they need and stop them from. वो मजबूरी से जा रहे हैं. They have no choice.
Exactly, sir. Exactly.
They have nobody is interested in having a soup in China. So they are not interested in, but we have to offer them the right things there. We need to have mold cities. We need to have industrial clusters which are having an ancillary all around you. You cannot expect a fresh entrepreneur to put all the machinery, have all EDMs and all CNCs and run the show. He needs to have a network of ancillaries. Everyone gets their specialty business and he also runs his show. So these are all the things that we will need to develop and speed up on. Tooling education, we need to have integral sandwich type of courses. 4 saal ke baad, when he is coming, he is again learning the same thing. This slows us up. So we need to have integral pattern of education. We need to have mold cities. This will only help us, cater to the demand of thousands of molds, which are in all sectors, not
so
only
something
automotive.
something like you're saying, something like what China has done in China. We should have something like that kind of a manufacturing support within the country.
Yes, wherever there is an automotive cluster, an OEM cluster, we should also have a tooling cluster around it, which helps to, be part of that industrial park.
So, sir, what are your thoughts on conformal cooling as a tool maker? Does it give you an added edge?
See, conformal cooling as a tool maker, when we see that, if it is considered, the cost is considered in the beginning stage, it really helps. in a later stage, as Mr. Abhishek also pointed out, many people find out in a later stage that this will need to be cool. And then the OEM is limited by its data. The PO has passed. Now we cannot get the approval. So the burden of the cost then comes to the tool maker. So if we can, somehow avoid that burden, and the OEM and the tier one, who are the real beneficiaries of this advantage, are part of this, then it becomes really fun.
Yes.
From a tool maker's perspective, if I see how conformal cooling can help a tool maker, it can help him reduce the number of trials. It can help in the pain through, part prove out. Aapne conformal cooling nahi kiya hai, and then you're struggling with higher cooling time. You're struggling with parts which are warping, and you want to somehow work around a way to find out and just sell the tool as soon as possible. But you are taking 10 trials for that, and you have not accounted for those 10 trials in your mold cost. How do you cover up all those costs? So conformal cooling will benefit in that way.
Yes, sir. So, sir, are you seeing a trend or a part screening exercise at your design end? Do you see do you do part screening that it should go on the conformal side, or do you have any kind of thumb rules for that kind of a decision making? All right, we should do conformal in this design, or we shouldn't do conformal in that design.
Yeah, since we have wide range of experience, we make around 400 molds a year. That's about one mold in a day. So we face a lot of issues now and then, and almost every product category has gone through our eyes. So we know the pain areas. So it becomes part of our initially DFM study to find out that where this is going to be a problematic area. And if we realize that, it becomes part of our feasibility studies that this may need to be conformal cooled, or we may need a separate beryllium copper insert here, which will allow our DFM studies, and so that we don't have the issue later on in production.
Sure, sir. Thank you so much, sir. I'll be coming back to you after talking to Virendra sir after this.
My pleasure.
And so we will be answering some of the questions from our audience today on live. All right, sir?
Sure. Thank you.
Thank you, sir. Thank you so much, sir. Yes, sir. Yeah. Hello, sir. Virendra sir, are you there?
Yes.
Hello.
Yes. Yeah, I'm here. Good afternoon.
Hello, sir. Good afternoon, sir. Sir,
good afternoon, everybody. Good afternoon, Kripal, and good afternoon all other panelists and whosoever is participating in this webinar.
Good afternoon, Virendra sir.
Yeah. Good afternoon.
So it is my pleasure to introduce one of the super brands of India, MotoCorp, and they are present at our webinar series. And it is my great pleasure to introduce Virendra sir, who is not just a general manager at MotoCorp, the tooling division, but he has been like a mentor, and he has asked us some difficult questions and some thoughts he has induced to us, and that's how we challenge ourselves and try to come out with greater solutions for our end customers. And Virendra sir has been a great driving force of conformal cooling technology in his organization, and trying to evangelize the product statement itself. So Virendra sir, do you want to introduce yourself, or do you have any opening comments?
That's good. So I was listening to the Kripal and other panelists also. I think it's a discussion was quite very well. This kind of discussion is very good for the industry also, because people come to know what is the technology and how we can use this technology. So since this Kripal was mentioning that they manufacture almost 400 molds in a year. So similarly here also, MotoCorp also, I think our average per year mold development is more than 600. So this kind of technology, I think will be going to be very useful and very adaptive in the coming future. So I, as a engineering project leader, take care of the mold and dies, and also for the new model development.
Exactly.
So this is just a brief introduction of myself. We have a team of 6 people around who take care of the development of toolings for the lighting and the body parts and the casting also. So here I think let's start.
Yes, sir. So, sir, I just wanted to understand from an Indian automotive perspective, from an OEM perspective, how this COVID-19, because you are involved with your supply chain, your mold makers, your molders, everyone, how do you seeing like the impact of COVID-19 in your supply chain currently? Because we are slowly opening up. So
Yeah, frankly speaking, I think 50 days for financial 21 have already gone. So those days cannot be recovered definitely. But personally, I see it as going to be a little. I'm on positive side because of this pandemic, because of this social distancing. But I feel that people will prefer their personal transport. So
yes.
people would not prefer the public transport like taxis, metros, buses. So I'm very much positive. I'm very much hopeful that the people who used to go for office or for job, daily commuters, they will prefer to use their own personal vehicle. So being a leader in the entry segment and you can say the automobile, especially two-wheeler industries, we
Exactly,
are
sir.
very positive, very hopeful. And we have, I think most of the two-wheeler industry and automobile industry have already resumed their work. We have also started our 5 plants. So from next month onwards, the production will also take its shape as per the plan. So initially, I think it will take one month time because there's an issue of social distancing. The capacities will not be same, but going forward, all the OEMs are also planning to increase the shifts. So this production issue will take a bit. I
So,
think
sir,
will be normal in the next 2-3 months.
yes, sir. So, sir, how do you see like as the automotive sector within the country was transitioning from Bharat Stage 4 to Bharat Stage 6, and in between this whole fiasco of the great lockdown, COVID has come across. So, how is the production and how is the decision making? How is the tool changes? How is the molding changes? Are you able to cater to the market and your supply chain?
See, the changeover from BS4 to BS6, it has already happened in the month of March.
Yes,
Because
sir.
first April was the target date, because there was a guidelines from the government that beyond 1st April, there will not be any restriction of BS4 vehicles.
Yes,
So
sir.
industry was almost at the edge of consuming the BS4 motorcycles, and BS6 was already there in the market since January this year. So I think almost all the automobile manufacturers, they have already migrated to BS6. So whatever production is going on nowadays, it is a BS6 only. And BS4, as far as our industry is concerned, BS4 has already been consumed in the month of March itself.
Great, sir.
So I think automobile industry is very much confident. Nothing is new to do in terms of BS6. Only we have to do regular mass production.
Yes, sir. So, sir, as a decision maker in an organization like Hero MotoCorp, how do you see Indian manufacturing taking on this great agenda of globalization to go local? And Prime Minister Modi is also talking about this. How is a decision maker like you going to work in the future, or do you have any specific strategy of tackling this kind of activity?
No, I think Hero as a Indian company, being an Indian company, we always promote to be local. And because of this pandemic situation, I think the world has it has changed already. So dependency to other countries, or you can say that other areas should be as minimum as possible. And our honorable Prime Minister, he has already given a that be local, buy local,
Yes,
and be vocal for local. So I will take it like that. So I think our company have been promoting the local manufacturing as well. I think people from the Sridevi tools, they are there, so they are witness that how much local content we prefer. So I think it is good. I take it as a very positive sign. It is a very positive sign for almost all the manufacturing industries in India. So with this Be Local mandate, I think we have to, this industry will grow in very fast pace. Only this local industry need to maintain the quality. Quality is very important, and we are lacking of skilled manpower. So this challenge will definitely come. Kripal was also mentioning that the students, they study in the college for 4 years, and once they join the industry, then they are almost like a child. So again, they have to be trained for 2-3 years. So we have to come up with the institutions which can give the practical training and can make a ready to industry kind of manpower. So that is
Yes,
the
sir.
requirement of.
So, sir, how do you take on deciding on, let's say, plastic part production? Like, what are the key decision checkpoints for you as a decision maker for taking a decision for making a plastic component? So, how do you take tool maker, molders, and everybody how to manage something like this?
See, we have to starting from the sketch itself. Starting from the sketch itself, we take care of the manufacturing concept of that particular bike. So from sketch to clay model, then clay model to proto CAD data generation, then CAD data generation to making a proto vehicle. The manufacturing concept, which method has to be adopted, which process has to be followed, which material, and what kind of manufacturing process. So we always keep in mind these basic requirements. So once this is over from the design board, and once any design takes shape in terms of you can say the prototype, then we come up based on the requirement of that particular component, because of due to is it aesthetically important, is it important from the performance point of view, which is it important from the strength point of view. So accordingly we decide the plastic material and also the what kind of process to be used to produce that particular components. And post that, then we go. I think then we post ordering of the tool. We do the joint design discussion and design finalizing activity along with the mold maker. So now I heard Kripal mentioning that once the tools are made, and then whether the supplier or customer or mold maker, they struggle for the to maintain the cycle time and to achieve the good product because of cooling limitations.
Yes, sir.
So my suggestion would be that all people like you who are leading the industries from design front, so you should come up front, and you should during the design stage itself, you should suggest that these kind of inserts or this kind of local inserts or core or local portion. You should go with the conformal cooling or
yes, sir.
so that during design stage itself, this can be taken care. And
yes,
if I think I don't feel that customer will not be ready to pay. Customer will always be ready to pay once they are confident that yes, if we will go with this kind of technology, or we will use any new technology that will pay us back in terms of performance, in terms of cost, anything.
So you are saying it is more than the cost; it is the value you are creating along with the project.
Yes. Because cost, I think one time, but every day you have to do the production, so you will be doing the firefighting every day. I think that is better to spend one time on it.
So all right, sir. Thank you so much, sir. I think that you answered my last question also beforehand itself. So thank you so much, sir. Thank you, Virendra, sir. And it was a pleasure hosting you. It was a pleasure talking to you. And actually, most of our audience today is from students' background and learning background. So it is for them. It is a great thing to hear from the people who are making the right decisions and making the right product for the country. And Hero MotoCorp and along with the other two-wheelers in India, they are the pride of the nation, and we are very hopeful that the industry leaders from India will take up the world someday very soon.
Yes, I think some people are asking the question if Ankit, you can take up. I think if
Yes,
they
sir.
are the students, somebody
Yes, sir.
was asking how to get the skill set.
Sir, I'll just golden color. So, sir, yes, sir. Skill sets. Somebody is asking about the skill set requirement for being a good tool maker, kind of this thing, sir.
So Kripal is there?
Yes,
Yes,
sir.
sir.
I can take that.
Yeah,
Question.
Kripal, I think you better take this.
Yeah. Actually, there are NTTF is one of the good institutes. CPET is there, so where you can enroll, get an advanced diploma in tool and die making, and then once you are finished with your course there, you can join the industry as a trainee, and then learn the aspects on the shop floor, which will give you more of practical insights into the how the mold is made, and this is how the journey from your basic diploma to tool making can evolve. So you can go
Yes.
via NTTF route, or a diploma in tool and die making. Advanced post-graduation diplomas are also available. It's a 1 year or 2 year course. Finish it, come to us, learn the trade of the skill, and that's how you become a good tool. Around
Yeah,
30.
Kripal,
Yes,
I would like to add to this. Earlier you mentioned that tool making is not a ordinary kind of job or ordinary kind of work.
Yes, sir. Yes, sir.
It definitely require people who work by heart, or like a
Passion, we got to.
Passion
passion.
is
Yeah,
Passion.
passion is must. Otherwise, it is not that kind of job which anybody can do. It is a highly skilled job, and you have to give your mind and heart into that. Then only you will be an expert. The biggest challenge I feel, Kripal, you must be agree with my point. In this kind of industry, people will work for 2 hours, then they think that they are the expert now, and immediately they will try to shift the industry for for a little bit salary up and those kind of things.
Yes, sir.
So that kind, I think that is the reason we are lacking of skill set. So the main reason going outside India is the skill set. The skill set these Korean and the Taiwanese and the Chinese people they've got. So those skill set I think we have to acquire, and we have to retain this talent also. This is a big challenge training this tool makers or from the tool making industries on the board. So this is a challenge.
So the key takeaway we can do is like the skill sets should be in an advanced level, and that comes with the experience of making good amount of tools, right?
Yes.
True.
True, sir. I agree with you, Virendra.
Yes, sir. So, sir, do you want to take like about how do you see an additive manufactured insert comparable to conventionally produced? Because a lot of people have questions about the
I
strength.
understand. Strength, I think, since the more larger industries, the big industries coming into this now. So this is going to be not a new technology for future. It is going to be that common technology soon.
Yes,
And the bigger players are entering into this market. Many more players are coming. Ankit, you will have a tough competition, I tell you.
No, competition increases
Yeah,
your
I think,
capacity.
definitely. So it is like that. So what I was asking with these companies that when we can do the mass production of this 3D printing. So my question with these 3D printer manufacturer was for the plastic as well as for the metal parts. So I'm looking for the technology wherein we can go for a mass manufacturing by 3D printing. So I think in this year, a few more companies will enter into India, and they will be offering the 3D printed steel insert and all.
Yes, sir.
So because conventional or CNC machining, they have its own limitation.
Exactly,
So,
sir.
and especially in terms of curve profile and in terms of integrated shapes or thin inserts, they have the limitation because of the machining, the strength and all. So in those kind of areas, the 3D building, conformal pooling, I think it is must. It is going to be a regular part, and most of the people
So,
will
so
start using this kind of technology.
what is your experience with simulation as an answer to a lot of tool making? Because it should be under a closed loop, like a decision should be under a closed loop. Because I think you are also sitting in a decision making seat. Kripal sir is also sitting in a decision making seat. I also am sitting in a decision making seat. So that is like, do you see having a closed loop make it easier for you to take a decision?
Of course. I think once any customer send for a query, and the tool manufacturer, when they do this simulation study, they revert with some first kind of feasibility study. I think they should start from there itself. They should start suggesting the area, the part where they would like to go for conformal cooling kind of thing. So I think it will be great if they will come up at that time. So before even finalizing the commercials, the OE and other customers, they can understand the technology and understand the benefit of going by this, and then it will be a part of integral design. And with the help of people like you, Ankit, I think it will be definitely it will be profitable, or you can say the improvement for the all over for the customers, for the suppliers, and for you people also. It will be win-win kind of situation for all.
So sir, I take today as a very big this thing that I'm talking to one of the most important pillar of our Indian GDP, which is manufacturing, and we all, at least like Virendra sir, Kripal sir, and I can also vouch, like in India, being from the manufacturing background, how tough it is to do a decision making of making in India, and rather than a temptation to buy it from outside India. So do you see that being increased slowly because of the talent pool in the tool making space? People have been increasing that kind of talent pool, or having that kind of a scientific to the problems treatment.
Hello.
Yes, sir.
Can you repeat your question again, because there was some issue with the voice.
Oh, okay, sir. So, sir, what I'm trying to ask you is, like, as we are coming from the most important sector of Indian GDP, which is manufacturing,
Yes.
and is it coming, like, as you both are experience of almost like 20-25 years into the industry? So, are you seeing that as a trend that Make in India is going to be possible, and we will be able to deliver better products? Because as Hero MotoCorp delivers one of the best products within the country, and they have been exporting a lot. So do you see there is a drastic change in the requirement?
Yes, Ankit. Personally, I am very much positive about this Make in India, and now with this new slogan, "Be local, buy local," and vocal for local. So definitely, it is going to be very beneficial, and the local industry. Even in this pandemic time, the local industry, they are very positive with this kind of statements given by our honorable Prime Minister. So, and most of the industries, they have already started their plannings, how to boost up their manufacturing, how to improve the quality level, how to improve the quality, and how to cater, how to make a brand, So
Yes,
only issue is that if you have to make a brand, you have to focus on the quality. Right? Customers are there to give customer are there to give any kind of charges or the money. Customer never ask for the discount if you have the good product. So now things will be changed, and because of this local slogan, customer will prefer to go for a local. And I personally feel that people will see the change in coming, 1 or 2 years.
Sure, sir. Sure, sir. Thank you, Virendra sir. Thank you for joining us, and it has been a great pleasure hosting you, hosting Kripal sir in this. And Kripal sir, do you have a closing comment onto what we were speaking about?
See, there's good things, bright things to look up to. The people have, the young generation has to, take up this mantle, speed up, be ready to work hard. That is one of the prime most criteria for everyone now. We have to be ready to work hard, burn the midnight oil, and do as much as possible, to gain ground that we have lost to other countries outside of India. So
Yes, sir.
we need to keep on. I hope that everybody has used these 3 months to gather as much as knowledge and inputs they can to do well for whatever industries they are working in. But then if we lose this opportunity, this crisis is an opportunity for us. If we lose this, we cannot wait for another COVID-20.
No, sir, we should never.
Let us make most of the opportunity that comes. There is going to be pain for next 6 to 8 months, 1 year, but somehow we have brighter things looking up to us. So technology is going to drive the way. So the next generation has to be able to synchronize technology, and with the tool making is also an art. So both have to be synced together, and then we can really see great days for the tooling in India.
Thank you so much, sir. Thank you, Kripal sir. Thank you, Abhishek, for joining us, and thank you for the audience joining us today. We got a very overwhelming response. More than almost 200 plus people joined today, and it was a great pleasure to introduce about the conformal cooling technology, and it was great to host such great manufacturers right now in this tough situation we are in, and we will make sure that we come out as a prosperous country again. Thank you so much. Thank you, everyone. Thank you for your time.
Ankit. Thank you, Virendra.
Thank you,
Virendra. Thank you, Kripal ji.
Namaskar, Virendra. Thank you to be here.
Yeah,
good to hear you.
Thank you.
We'll
Thank
catch
you,
up
thank
later.
you.
Thank you, sir.
Thank you, sir.
Thanks.
Thank you.
Definitely.
Bye, Abhishek. Thank you.
Bye, everyone.
Sankha,
Yes, sir.
any closing
So,
comment?
yes, sir. The poll actually, we ran a poll. I would like to share that result for people. You can also pitch in about the next webinar as well. I'm sharing the result of the poll as well.
Yes. So our next webinar will be on topology optimization. So it is also one of the key beneficiary out of the additive technology. So what we are now discussing is the derivatives out of the possibilities of additive manufacturing itself. So the poll results are out. More than 45% people are saying that it will be improving the quality of the final component, and 41%. So I think I was rightly inclined that people are rightly placed with the money, and people talk about money a lot. So 41% people are talking about the profitability increase, and 5% are saying about the reduction in the waste, and 10% are talking about the throughput. So the throughput is also a cumulative effect of increase in the quality and also increase in the profitability. So that is where we will be closing our webinar today, and hope to see you on 26th when we'll be talking about in-depth knowledge about topology optimization as one of the solutions from additive manufacturing. Thank you for joining us. Thank you, everyone.
Thank you, Ankit.
Thank you, Ankit. Thank you very much. Very great session.
Thank you.
So I would like to close the webinar. Thank you everyone for joining in. Thank you, Virendra sir from Hero MotoCorp, Mr. Abhishek Tiwari, Moldex 3D, and Kripal Bedi from Sridevi Tools. I would like to also thank Mr. Ankit sir and our associate partner Tagma, as well as our media partner Manufacturing Tech Update. Thank you everyone. We'll be seeing you soon in the later sessions.
Thank you. Thank you, everyone. Thank you.
Thank you.